Hi everyone and welcome to Get Started with Serverless Event Buses. My name is Gunnar Grosch. I am a developer advocate at AWS. So this is our architecture right now. Our customers are able to order food and get it delivered from our restaurants. So what's the problem now then? Well, the problem now is probably a good one because what happens when we want to expand the business? What when we want to add restaurant number 2 to the mix? When we want to be able to order from restaurant number 3? Well, we can continue with the architecture that we have right now, and we can add additional code in our Lambda function to be able to then order through the API from restaurant 2 and from restaurant 3. But that can get messy pretty quickly. And with the synchronous nature of our API calls, it means that we have to handle a lot of the heavy lifting with doing these calls. So that brings us to another way of solving this, and that is events, and events with Amazon Eventbridge. So events today is a common integration pattern that's using the changes in state or update or things that happen within your application. For instance, an item being put in a cart or something being ordered. And event-driven architectures, they can really help you improve scalability, fault tolerance, and agility by reducing dependencies between different components within your application. And as events are asynchronous, you don't need to wait for a response to move on to the next step. And this also improves resilience and reduces these dependencies. So, to do that, I want to introduce you to Amazon Eventbridge, and that is our serverless event bus service that makes it easy for you to connect your application to data from a variety of different sources. Eventbridge delivers a stream of real-time data from your own applications, from SaaS applications, or from AWS services, and then routes that data to different targets. So looking at the architecture of Eventbridge, it might look a bit complicated, but it actually isn't. Eventbridge is fairly easy to get started with. So first off, we have the event sources, and an event, as I said, that's something, a change in an environment, something that happens. And this could be an AWS environment, a SaaS partner, or one of your own custom application. Next, we have what's called the event bus, and the event bus receives these events. Your account has a default event bus, which receives event from AWS services. Then you can also create your own custom event buses that you use with your custom applications. And you also have the opportunity to use a partner event bus to receive these events from SaaS partners. Next, we have rules, and rules match the incoming events and routes them to targets for processing. A single rule can route to multiple different targets, all of which are then processed in parallel. Rules aren't processed in any particular order. And next, we have the targets, and a target is a resource or an endpoint that Eventbridge then sends an event to when the event matches the filter pattern that we set up for our rule. And you can define up to 5 targets for each rule. And a target, well, that can then be, for instance, Amazon EC2 instances, AWS Lambda functions, an SQS queue, or any type of service or endpoint. And we also now have the opportunity to use what's called API destinations. And destinations are HTTP endpoints that you can invoke as a target of a rule, similar to the way you invoke these different AWS services. And this lets you route events to HTTP APIs, REST APIs, in a very easy way. Compared to if you have to write that logic and maintain it yourself in, for instance, an AWS Lambda function. So with the power of events and Amazon Eventbridge, then let's try to solve our problem. So this is our architecture. We're taking a step back, and instead we're adding Amazon Eventbridge into the mix. And we're changing our Lambda function that previously handled that API call to our restaurant. Now instead, that is creating an event and putting that into our event bus. We then set up a rule to then filter on these events that are created, so we're able to then match those with the target, and the target being a restaurant with an API endpoint. So if we zoom in a bit on this, we can see that we have our Lambda function that creates an event that is put into an event bus. We have a rule to match that event, and then we have a target that is our API, or the restaurant API. So next then, well, the next logical step is to add restaurant number 2, a rule for that, and an API endpoint for that. And then we have restaurant number 3, and so on and so on. So with that, let's build. First step for us is to do the restaurant selection. So we're able to add restaurants in the order, and then to update our order function to be able to create these events into the event bus. So let's look at that. Switching over to VS Code. Start off with our payment function. We're now adding restaurant as part of the order. So the submitted order will now contain a restaurant, the name of the restaurant. Next up, when we're submitting that order, that is then saved into DynamoDB containing that restaurant name. We're updating our SAM template, and in that, I'm now adding an Eventbridge event bus. We're setting the property, which is the name of that event bus, which is a unique name for each event bus. We're calling it restaurant event bus in this case. Next, I'm updating my make order function and adding a policy to be able to, for that Lambda function, to have the permissions to save events into our event bus. And I'm also adding an environment variable so that the Lambda function is able to know the name of our event bus. With that in place, we can now switch our focus to our step functions. And what we want to do there is just a quick change. Previously, we just sent the order ID on. Now, I've removed that limitation, so we're now passing the entire order details onto our Lambda functions. And then updating the order function, I can now make use of both the order ID and the entire order details, which is the event that is passed onto our Lambda function at invocation. So using that, we can now have a look at the restaurant manager. And if you remember, the restaurant manager previously was just basically code that should have been the API call, but just did the logging. Now, I'm using the AWS SDK to be able to use Eventbridge. So I'm getting the order details that is sent into the restaurant manager, and then I'm setting up parameters to use with Eventbridge. And these parameters contain, first off, the request data, the details of our order. The detail type and the source is set to Detecto and restaurant order. And then we have the event bus name, where to then put this event. And if we have a look again in our SAM template, we can see that I'm using the environment variable from there. And these details, these parameters, I'm putting them into CloudWatch logs for us to see, but then we put them into Eventbridge. And then we're returning our order ID. All right, so with that in place, let's switch over to the Lambda console and have a look at how this looks. Opening my make order function. And let's have a look at the monitor tab and open up our logs, the log stream for this Lambda function. There we go. And now while that is loading, I can open up Postman to then create a new order. And now with the addition of a restaurant and adding that restaurant name. So let's go with restaurant 1. And now I can submit that order. Right. Switching back to CloudWatch, let's refresh. We can now see that we have a new entry. And let's open up that and see what got logged into CloudWatch. All right, so we can see that we have the details of the order, we have the products, we have the detail type, we have the source, we have the event bus name. So that was the parameters we used in our function. So we can see that it is working. We are now able to create an event, and we are able to then put that event into our event bus, and then we can also log it into CloudWatch as we saw. All right, so next step then, well, it is to add our first restaurant so that we're back to where we were before. We have one restaurant that we're able to order from. And we're gonna make use of our SAM template to do this. So first off, I'm adding a parameter. This parameter is for the URL of our API. Next, I'm adding a connection for my API, and the connection contains information about how we're connecting to that API. For instance, authorization. So we could use API keys, for instance. In my dummy example that we're going to use now, we don't have any API keys, but if we wish, this is where we would enter those. Then we set up the API destination. And the destination, that then contains some properties. The name, first off. Next up, we set up, we connect it with our API connection. Then we add the invocation endpoint, which is our parameter. Choose a post for the HTTP method, and then we can set a rate limit as well. We've set this at the default of 10 invocations per second as a limit. Then we need to define our rule, how to match our event with this specific API endpoint. So we're setting up an event rule. I've set this to enabled now. I connect it to my event bus. And then I set up an event pattern. So the pattern contains the three things we saw before: our source, our detail type, and the detail. And these should then match what I had in my restaurant manager. So source, detecto, detail type, restaurant order. And then the detail, that is what was sent through the order. All right, so I've added detecto, I've added restaurant order, and then we have restaurant, in this case, restaurant 1. Then we set up the targets. Where should this rule then route our events? We're routing them to our API destination. Now we just need to give Eventbridge permissions to route events to this API. So we're setting up an IAM role, and this IAM role will then have the assume role for Eventbridge. And then we're adding a very simple policy to allow Eventbridge to invoke API destination, and the resource is our restaurant 1 API destination. And with those changes to our SAM template in place, we can then open up a site that's called webhook site for testing our API, creating a unique URL that we can use as the API endpoint. Now I'm deploying our new version and then entering that API. So in my parameter, the one I defined in my SAM template, I can now paste my unique API endpoint. So this is just for test. That would be the endpoint of our restaurant if this was a real example. So now I can go back to webhook site, open up Postman, and now let's give it a try. Let's make an order to restaurant 1. Sending that, and let's have a look. Looking at webhook site now, our test API, we can see that it has received a request, a post containing a restaurant order. It is from the source Detecto, and it contains all of the details for our order that was sent through the site. So this works. We're able to now use an event and use API destinations and route it to restaurant 1. So let's try enter restaurant 2 instead to just make sure that we're not catching all. And that order does not appear in our test API in this case, meaning that it works. Our rule catches the one that are aimed for restaurant 1. So next then, let's add a second restaurant API destination so that we have 2 different restaurants. That was the goal of the changes we were making. So to create the second restaurant, first off, we need to add a new parameter for the API URL for our second restaurant. And then it's a matter of copy pasting and just changing from restaurant 1 to 2. So we create a new connection, we create a new API destination, we create a new rule that is instead matching on the pattern restaurant 2 instead of restaurant 1. And we set that to our restaurant 2 destination. And the last thing we need to do is to update our policy so that Eventbridge is able to also use the second API destination. Now let's deploy this. I of course need a second test API as well to get this working. So for restaurant 1 we have the same. For restaurant 2, let's open up a new window and create a unique URL for us to use. And let's use that for restaurant 2. Deploying. And now let's have both windows open and open up Postman as well. So first, let's post to restaurant 2, and that works. We're getting an order into restaurant 2, the API destination of restaurant 2. Let's change to restaurant 1 to see. And yes, that also works. So we can see now that our 2 different rules are matching on the restaurant name, and they are then being routed to the correct API endpoint. Awesome. So the last thing I want us to look at is what happens if an event is not delivered? What happens if, for instance, the API for restaurant 2 isn't responding as intended? Well, then we're able to add what's called dead letter queues, and we can use retry policies for that. And a dead letter queue is simply an SQS queue that will then be receiving messages or events that we can't deliver through our API endpoints. So let's look at that. And to do that, we're opening our SAM template once again. First off, we need to create our dead letter queue, and that's just 2 rows of YAML where we're creating a new SQS queue and naming that orders DL queue. And then on each of our rules, we then define a dead letter config and point that to our newly created SQS queue. Then we also set up a retry policy. And this is optional, but by setting a retry policy, we can then define the retry behavior, how many times it should retry and over how many seconds. And when it's done that, it would instead leave that message in the dead letter queue. All right, so that's defined for both of our rules now. If we add restaurant 3 and 4 and so on, we would do the same. Then we need to create a policy, once again, to allow Eventbridge to be able to store messages or send messages to our queue. And we have one for each rule. Now let's try this. So I'm sending an order to restaurant 2 now. That appears in my API test site. So now to try this, I'm going to delete this URL so that my API endpoint isn't existing anymore. So now if I try a new order, we don't have any API responding. So what's happening now? If I switch to the SQS console, we can then check our queue to see if something ends up there. First off, Eventbridge will do the retry behavior we configured 4 times and so on. But let's check the queue to see if there are any messages there, since we weren't able to deliver this to our API. So polling for messages, we can see that yes, there is one message in the queue. And that message, well, it then contains the message data, the data that we were trying to deliver through the API. And by using this, well, we can then use those events and either manually resend them. We can notify, of course, if there are messages in our queue. We can set up a Lambda function to poll for messages and so on. Trying it again, we can see that this second message also ends up in the queue. So now we have a dead letter queue in place and it works. That's great. So we won't lose any messages. And with that then, well, that brings us to our takeaways. So first off, event-driven architectures improve scalability, reliability, and agility. And API destinations in Amazon Eventbridge, it enables you to easily integrate with third parties using REST APIs, so you don't have to manage the code for those API calls. And you should use dead letter queues to handle message failures, so you don't end up losing messages. And also, check out the retry policies for each of your rules to set the maximum number of retries or the maximum age of your events. If you want to try this out, all of the code and other resources are available at this link, grosh.link/letsbuild, or just scan the QR code you see on screen now. And with that, my name is Gunnar Grosch. I want to thank you for joining me in this session where we got started with serverless event buses. Thank you very much.
Well, hello there, you amazing tech people, you. Listen, thank you so much for stopping by to check out this video. However, there is so much more great content out there to be found. So make sure to subscribe to the Build on AWS YouTube channel. And while you're at it, click that bell icon to be notified about the latest and greatest in videos made by builders for